Hello, and welcome to Compute 175 Python Review. In the last video, we saw how Python provides us with values of various types, such as ints, floats, and strings. In this video, we'll see how we can use variables to store and recall calculated values for future use. Take the following example. I'm going to a potluck tonight, and I'm making my signature guacamole. I have to stop by the store and get some ingredients. So, let's use Python to calculate how much I'll have to spend. I'm making guacamole for a party, so I'm going to be buying at least 2 avocados. So 2 times the price of an avocado, which is $1.78. And I'll need a lemon at 77 cents. I'll need an onion at $1.29. And finally, a bottle of ground oregano leaves at $5.99. Well, hold on. $11.61 is just the subtotal. I also have to calculate the tax before I get to checkout. In Alberta, the sales tax is 5%, so I'll have to multiply all those values again by 0.05. So let's copy those values, and then do 0.05 times, in brackets, all that stuff. And now to get the total, I'd have to type all those values again yet another time. Python gives us a way of remembering values that were previously calculated. This is called a variable. Variables allow us to assign a value to a name. So, I'll assign the price of an avocado to the name avocado. Avocado equals $1.78. Python can now recall the value by the name we gave it. So if I just simply type avocado, it will give us back $1.78. Similarly, if I do a calculation with the name avocado, Python recalls the value of avocado and uses it in the calculation. This funny thing with the equal sign is called an assignment statement. It computes the expression on the right-hand side of the equal sign and stores the result, allowing us to recall the result using the identifier on the left-hand side of the equal sign. From now on, I'll refer to identifiers as names. I'll go ahead and assign the price of each item to an appropriate name. Avocado equals $1.78. Lemon equals 77 cents, onion equals $1.29, and oregano equals $5.99. Now, to calculate the subtotal, I will do it iteratively, adding one item at a time. I'll create a variable called subtotal, which initially starts at 0. Now, I'll assign it the price of 2 avocados. Subtotal equals 2 times avocado. Hold on. I said subtotal was at first 0, but later I said subtotal as the price of 2 avocados. Assigning to a previously used variable like this is called reassignment. Often, when we reassign a variable, we use the previous value of the variable in the calculation. For example, if I were to add the rest of the items to the subtotal one by one, let's start with the lemon. So subtotal equals, we'll use the previous value of the subtotal, plus lemon. And now we can see that the subtotal has updated. Similarly, I'll reassign subtotal to the previous value of subtotal plus the price of an onion. So subtotal equals subtotal plus onion. And let's see how it changed. Finally, I'll add the price of oregano in the same way. Subtotal equals subtotal plus oregano. Let's look at that final value of the subtotal. Now that we have that, I can calculate the tax. So I'll say tax is equal to 0.05 times the subtotal. And now I can finally calculate the total. Total equals the subtotal plus tax. Let's have a look at that. Whoops, that figure has one too many digits. I'll use string formatting here to fix that. So let's print the %.2f of the total. We'll talk more in depth about string formatting in a future video. Using variables, we've arrived at our final answer. Now, I'd like to cover some common mistakes that people make when using variables. Variable names are case sensitive, so you have to type it exactly as it's written, including the letter case. For example, if I type total equals subtotal plus capital tax, we get a name error. This means that Python can't find the variable named tax spelt with a capital T. We have to match the case exactly. Similarly, if I asked for subtotal, but I missed a letter while spelling it, so total equals subtotal plus tax, Python raises yet another name error because we mistyped the name. Make sure to check your spelling and try again. Another mistake is using invalid characters in an identifier. Identifiers cannot start with a digit. So, for example, if I wanted a variable for the price of 2 avocados, what happens if I named it 2 avocado equals 2 times avocado? I get a syntax error because Python does not recognize this as a valid identifier. I can always add the digit to the end, however. So, for example, avocado 2 equals 2 times avocado. Variable names also cannot contain spaces. So, sub space total is an invalid variable name. So, let's try using that. Similarly, variable names cannot have hyphens, so sub hyphen total is also invalid. Instead, we can use underscores to separate words in a variable name, like sub underscore total equals 2 times avocado. Now that worked. We can also use the convention of capitalizing each separate word in a variable name, like sub capital T total equals 2 times avocado. Sub capital T total. This convention is called camel case. Finally, Python forbids using existing keywords as identifiers. For example, none is a keyword in Python, so let's try assigning it to 0. None equals 0. This is a syntax error, as the word none is a keyword in Python. The solution is simply to use a different word that isn't a keyword. For a list of Python keywords, you can type help keywords. We've seen in this video how to use variables to store the results of computation. We've also learned how to assign a value to a variable, and we've learned that reassigning variables replaces the value previously stored. We also learned about some common mistakes when using variables and how to avoid them.